Good afternoon, everyone. Thank you for joining us for the session now. We'll be running for about 45 minutes through to 2 o'clock. So we're going to be exploring working smarter, not harder, how smart and flexible heating systems can improve performance and the customer experience. So first of all, just to say, so I'm Alex Hobley. I work for the Department for Energy Security and Net Zero. And welcome to the Future X Heat Takeover. So Innovate UK, the Carbon Trust, and the Department for Energy Security and Net Zero, DESNZ, have collaborated today to showcase some of the cutting-edge solutions for heat decarbonisation, which are being funded for UK innovation programs. We've had and will continue to have today a packed lineup of panel discussions with leading innovators, some of which are on my left-hand side here, discussing all aspects of low-carbon heat innovation, covering survey and design and maximising the benefits of smart and flexible heating systems, overcoming cost barriers, supporting retrofit. Details of the sessions are in the programs and on the app. We also have behind us several stands from projects and organisations we're funding. Please talk to them, find out more. Heat accounts for nearly 20% of UK carbon emissions. And our discussions today can paint a vivid picture of how innovation can drive market innovation and decarbonise heat. So we're going to explore how smart and flexible operation can optimise performance of low-carbon heating. We'll have micro considerations such as consumer bills, macro considerations such as virtual power plant, grid benefits will be discussed to place smart and flexible systems at the centre of an efficient net zero system. And our speakers will cover the fundamentals of smart controls, how optimization, including optimization to weather forecasts, time of use tariffs, and how demand-side flexibility can reduce consumer bills. So, I've introduced myself very briefly. At the department, I'm taking care of some of our heat pump innovation programs, namely Heat Pump Ready Stream 2, where we're developing tools and technologies to support heat pump deployment in the UK. We've got three great speakers here. We've got Joe McMullen from AirX, Mark Lufkin from Wonderwall, and Tom Lowe of Thermal Storage UK. I'm now going to ask them to limit themselves to 60 seconds to introduce themselves, as I'm sure they can do a much better job themselves than I can. So I'll pass over in order, starting with Mark.
Thanks very much. Mark Lufkin, I'm Chief Product Officer at Wonderwall. My background's actually nothing to do with building at all. I'm a computer engineer, and the passion I have and what we drive at Wonderwall is about using smart technology, intelligence, data to make our homes better. It's along the lines of, you think back 30 years, how our cars, some of you won't remember, but how our cars used to be. You used to wind up windows. I can remember this stuff. No sat-navs, they weren't as efficient, and how they've converted now to just about be self-driving cars. And if you look, on the other hand, at our homes, they're still being built in pretty much the same way as they were 100 years ago. So it's about how do we use some of that technology to make our homes better, to bring them into the 21st century.
Hi there, I'm Joe from AirX. We set out with a mission to try and tackle both climate change and fuel poverty, doing so by developing smart energy-saving ventilation products. What they do is they detect conditions inside and outside of homes and optimize ventilation accordingly. We're looking for conditions that could lead to problems such as damp, mold, timber rot, and generally unhealthy environment for both buildings and occupants. And where required, allowing ventilation, but when not needed, reducing the amount of airflow through a building, reducing heat loss by around 12% and leading to around a £250 a year reduction in energy bills for the average UK household.
Thank you. So I'm Tom Lowe. I'm the founding director of Thermal Storage UK, which is a trade association representing companies that make heat batteries for hot water and heat batteries for space heating. Two of those organisations are actually part of the Innovate UK Clean Heat cohort, so I'm to some extent representing them today on this panel. So that's Tepio, whose stand is somewhere over there, who have a space heating product, and Sunamp, who I haven't found their stand yet in the half an hour I've been here, but they're somewhere over there, someone in the crowd's showing me, who have a hot water heat battery product. My background is mostly in the energy sector, working for energy suppliers, the likes of Ofgem and consumer groups as well. So we're very big on heat flexibility, because if you haven't come across a heat battery before, the main benefit you get from a heat battery is the ability to flex in the same way as you would with, say, an electric battery. But instead of storing the electricity as electricity, you're storing it as heat for future use. So I'll be talking a lot about time of use towers, I suspect, over the next 40 minutes or so.
Great, thanks everyone. So I'm going to make sure we've got time at the end of the session for questions, so we have an interactive session with our audience here. So we'll have a sort of a panel discussion through to about 10 to, and that'll leave at least 10 minutes for question and answers. And just to prep my panel here, at the end of the session, I'll be asking each of you to wrap up, to pick one policy change or a technological innovation that you feel will support reducing customers' energy bills. So a little bit of a heads up there. So we'll kick off, sort of setting the scene for today's talk, really. And really, I'm interested to hear from you about how you feel customers can benefit from smart controls. What is it about smart controls that a customer could benefit from?
So from Eric's point of view, we are smartly controlling ventilation in homes, and by doing that we're able to reduce heat loss and reduce energy bills. That's a really big obvious saving. We're able to do that whilst, by choosing to ventilate at the right times, we're able to provide the same total amount of ventilation to a home over a longer period of time. So reduce it, so make sure there's not any unintended consequences, nothing that leads to damp, mold, timber rot, unhealthy environments, I've just said. But it's that smart control which enables the right action to be taken at the right time and for the best possible outcomes for consumers.
I'd agree with the bills piece. So one of the things I always consider is, if you talk about decarbonisation of homes doesn't necessarily mean lower bills. But what we've seen time and time again, people are motivated by what they can save, the reduction in their bills. So as I see it, or as we see it, the primary goal always has to be to reduce those bills, because a reduction in bills automatically means a reduction in the carbon emissions of our homes. So that has to be a primary focus. Of course, you shouldn't forget the bigger picture, which is we're doing all of this to save the planet. So it is about decarbonisation and leaving a better planet behind for our children, our grandchildren.
Thanks. So I think it probably depends on the product you're looking at as to how easy it is to have smart controls in place. If those of you who are aware of the PAS 2035 framework for building retrofit, you'll know that some products are quite detached from the rest of the product, the rest of the home. So if you were to install solar and batteries, for instance, having those products is quite straightforward to install. You put it on the roof, you have the battery on the ground floor somewhere, and then having the control for that is relatively straightforward, because it doesn't have to integrate with really anything else going on in the home. The same would be true for an EV sitting in the driveway somewhere as well. It is more complicated once you get into the world of heat, because you're having to think of more parameters. You're having to think of external temperature, internal temperature, preferences that the homeowner might have. And also, if you're trying to make that electricity as low carbon as possible from the grid, you're going to want to try and maximize the times you're going to be using low carbon electricity. So that might mean charging up at night and then storing the energy for later. So heat batteries would have a role, but also maximizing any solar you may have already installed in the property as well. So during the day, you can then create and store heat for later as well. So it becomes more complicated for heat. And I think ideally what you're looking to do is integrate all of those different products in due course. There isn't, I mean, maybe others in the panel may have a view on whether there's a product out there that does this, but it is difficult at the moment for a homeowner to integrate all of their different appliances. If someone had solar, electric battery, a heat battery, a heat pump, and an EV, the chances of you actually being able to integrate that well today is quite difficult, especially if you then try and put it with the time of use tariff, because there aren't that many time of use tariffs out there that will operate that flexibly. But I might be team Mark up.
I was just going to say, that's exactly what we do. Thanks for the plug.
Thank you. So we've touched upon their sort of areas of the efficient operation of a smart energy system and flexible usage. What is there that can be gained for the consumer there?
Ultimately, it comes back to the bills again. But if you, in a best case scenario, if you're doing this right, you integrate all of your pieces together, you get your heating right, you're maximizing the use of your solar, maximizing the use of your off-peak tariffs, you're exporting at the right times, you can get to a situation, and using flexibility, you can get to a situation where your home costs nothing to run, so you've got zero bills to run your home. Or you could even get to negative bills where your house is becoming like a little mini power plant, supplying energy back to the grid and helping decarbonize that grid. So the ultimate situation, you're not paying for your energy.
Yeah, for me, the ideal outcome for the consumers is that they get the same outputs, i.e. thermal comfort, without having to interface with 20 different devices, and without having, not sacrificing in terms of paying more or complications. So the systems have got to be set up in such a way that they're getting, again, that comfort that they need. They're able to use their electrical appliances when they want, but we're achieving the objectives that I have in terms of reducing bills, eliminating fuel poverty, and tackling climate change through carbon emissions.
Yeah, I think I'd agree with that, and I'd probably also add there's that element of control that you get as a consumer. If you've got the smart controls in place, you can actually begin to start utilising the products in the way that you want to. It's also quite addictive. So if you've got solar panels and you've got an inverter and you've got an app off the back of it, watching, for instance, the solar come into your home and then working out whether or not you say want to charge your EV, which a question I would in the summer in particular have to try and juggle is, do I want to put it into the battery, do I want to put it into the EV, or do I want to utilise it in the home? That's surprisingly addictive. I didn't think I would be looking at my app 7 or 8 times a day in the summer. Now, I do work in the energy sector, so perhaps I'm not normal in this regard. Maybe most people would rather automate this fully, but I quite like having that control and being able to utilise my app and at the touch of a couple of buttons, decide where my solar is going to go and how best to use it.
Great, thank you. So in considering smart and flexible heating systems and considering what is out there within the marketplace and what might be coming into the marketplace and what we can anticipate. Could you, panelists, talk a little bit about what do customer propositions look like at the moment, and any thoughts on how these could be made, ensured to be made appealing in an economic time when money is tight for many.
So we'll go back this way. So when it comes to heating, there are options out there for consumers in terms of what they want to do to decarbonise. If you want to get a heat pump, there are obviously grants out there today, the £7,500 grant that the UK and Scottish governments are providing. In Scotland, it's actually slightly more because you can actually get free 0% interest loans up there as well. So there is financing available. There are grants available for some products like heat pumps. There are low temperature heat pumps, there are high temperature heat pumps. There will be trade-offs you'll have to consider between those two types of product. Higher temperature heat pumps tend to have higher running costs than lower temperature ones, but lower temperature ones have got more upfront cost. When you're getting those heat pumps, you may want to think about, again, heat flexibility. So how big is your hot water storage, how big is your heat battery storage, if that's the route you go down, and are you optimizing that product to run sort of low and slow in the jargon, so keeping the product on regularly at sort of lower temperatures, or are you going to sort of flex it up and down in line with something like a cozy tower for an Octopus Go product or an Octopus Agile product. Other options, if you were looking at, for instance, if you didn't have space for a heat pump externally, or you're struggling for space internally, you could look at something like the Tepio product, the zero emission boiler. I've already said I represent them as a trade body, so I'm going to name drop companies during these answers. That product has the advantage that it runs at roughly the same sort of temperature as the existing product in your home if you've got a gas boiler. So you shouldn't have to do radiator changes or other pipe work. It's a reasonably quick sort of drop-in replacement product for a gas boiler and get you onto zero carbon electricity much more quickly. But I think there is definitely a question. There's an upfront cost here. There's a capital cost consumers are going to have to face as we make this transition. Costs will come down as products scale up. So we've seen that in solar. We've seen that with EVs. We're now seeing it in batteries. So the next thing we're scaling up should see costs come down is in the heating sector. But we are very much at the start of that. We're installing hundreds of thousands of electric heating products at the minute. It will get up to millions in the next 5-10 years. But until it gets there, there is an upfront cost that people will have to face.
Yeah, I think for me it's ensuring that we're not ignoring the low-hanging fruit that's available to help reduce energy bills and reduce carbon emissions. So there's lots of exciting new technology coming out and there's lots of incentives out there. And I think it's important that simple, well-understood technologies like insulation, smart ventilation systems and the like aren't ignored, and that we don't rush straight into zero carbon heating. I'm not saying that in every single case there needs to be a whole house deep retrofit costing tens of thousands of pounds, but when there are really simple, straightforward solutions that can happen before the move to a zero carbon heating system, which can help ensure that the system's correctly sized and it's most efficient for that property, I think those options need to be taken.
Yeah, if I'm looking at it, putting in these solutions tends to cost quite a lot. I was looking at it this morning. It was a retrofit of a heat pump and putting it all in place, £20,000. You add this to a home, it also costs a load of money. You add the solar, the battery, all of these things cost an awful lot. Some of it is addressed through grants, so I do see some of the grant funding helping with that. But it's being primarily driven by the government. And, how much money has the government really got to be able to go and make this all work? I think for this to really scale, we've got to be able to unlock private finance, institutional investors to get into this model, to be able to go and fund the equipment up front and use some of those savings which are generated to be able to fund the equipment and putting it in place. And then we can see greater scaling. If everyone's got to pay the capital cost up front, that's really tough to do, and it limits the market quite considerably.
Great, thanks everyone. Something we were sort of talking about just a question ago there was around this, the control the consumer has on the home and controlling these systems. And I'm interested to know thoughts on how much of the control systems would be automated versus how much consumers will actively need to engage in. Do we require different levels of this for different consumers that have different appetites in these areas? Interested for thoughts on that, as it's often quite a personal issue, these things.
My opinion on it is let the system do what it's supposed to do. I was reading the interesting Future Homes Standard consultation, actually between Christmas and New Year, which shows how sad I am, but I was having a read through, and one of the documents in there was a manual for homeowners on how to use their heat pump. And one of the pieces in it was have a look at the setting of your heat pump for its temperature link between the external unit and the internal unit. And I was thinking, why the hell would a consumer want to know this? Why are they trying to set that? In my opinion, let the system do what it is. There's a few exceptions, of course, but for 99% of the population, I don't think they want to be messing around with these things. They want it optimized. And there's so many variables, the weather, the external temperature, solar gains, so the sun shining on your property, what's the cost of energy on a half-hourly basis, import, export, when are you going to be home, how long is your home going to hold its temperature, all of these things. You can't possibly think of everything to get it absolutely right. For a computer, it's dead easy. I am a computer engineer, of course, but in my opinion, let the smart control do what it's supposed to do.
I completely agree. For RX, we had two kind of different cohorts of early adopters of our technology. One was kind of large-scale retrofit programs, mostly assisting residents in fuel poverty, and the other one was early adopter, very tech-savvy people who wanted to have a play and fiddle with the devices. So the first cohort, their key thing they're looking for is warmth. They're replacing a traditional ventilation air brick with our smart air bricks. They didn't have to interact with that at all previously. Their home was well ventilated, not as warm as our system will make it, but they don't want to be spending every day optimizing, looking at graphs, fiddling out the best approach. There is a minority of people who are really tech savvy and they approach us wanting API access. They want to develop apps for using the data. They want to integrate with their own self-hosted building management system they've developed themselves. But that's a real minority. And if we're going to have the impact that we all need to create to meet carbon targets and the like, we need something that works for the masses. And computers are cleverer than people for things like this, and they are not going to get bored and forget to do something. They're going to do the right thing every time if they're designed and operated correctly.
Yeah, I guess I don't disagree that most people will prefer this to be an automated process rather than something they have to spend lots of time thinking about. I think in terms of the world of heating, if you're buying a product today and it's if you buy a gas boiler today, you don't have to think about how flexible that product is. Basically, it's a very simple, for most people, an off-on switch. If you've got a good engineer installing a gas boiler, they will be thinking about things like weather compensation and modulation. Now, I suspect if I was to do a straw poll, people who knew what their system was at home, they would find that isn't what they've currently got set up. So there is already stuff we can do today before you even get to the electrified world that would make controls smarter without consumers actually really being aware of what's going on for their benefit while keeping them warm. As you get into a world of electrifying heat, what you also want to then think about is how do you maximize the sort of carbon potential of the heating you're doing. So how do you make sure you're using solar and wind at the right times, and how do you make sure that you're not just, for instance, burning gas as backup power up in the system, which then is heating your home in a slightly different way than it was when it was going through a gas boiler. So there will be ways you can automate that. And there are products out there today that do that. So I've already mentioned the Tepio product. They've got an app that, for instance, will allow you to do that. You can see what's happening in terms of grid carbon intensity and what that then does for pricing. I said I was going to talk about time of use tariffs because I think that's the other part to all of this. As much as there's a very big hardware question that we need to answer, there's also that software question when it comes to how the time of use products that you've got to maximize the potential of the electric heating you have. That'll be true whether you've got a heat pump or whether you've got a heat battery or anything else. I think the big risk is we want to avoid having products that are direct electric without flexibility, because direct electric doesn't help with peak demand. So one of the great benefits of flexible heating is you can move consumption out of peak times, say 7 o'clock at night or 7 o'clock in the morning, which then means we have to spend less on the grid. So there's going to be a lot of grid build over the next 20, 30 years. There'll be a lot more pylons as we electrify heat, electrify industry and electrify transport. We want to minimize the amount of that we have to do because it will go on to consumer bills. It's not going to go into taxation, it'll go on energy bills. That's how the system works, and I don't think it's going to change. So the more we can flex out of peak with heating, transport and industry, the better it's going to be for the amount we have to spend on the grid, and the cheaper it's going to be in the long run for decarbonising the UK.
Great, thanks all. Thanks, Tom. And I think that's obviously a really interesting point, because while some of the questions have been focused on for the consumer, talking about how flexible heating can be a benefit to the network and the wider infrastructure is obviously really important and a real potential asset. of what this area can offer. Can I just check, audience, can you hear us okay? Or do you need us to talk a bit louder? A little bit louder. Okay, speakers, so just note that, maybe microphone a bit close to mouths, a bit louder. And Tom was mentioning there about hardware and software that we're using for this tech and what's needed. I was wondering, panelists, if you could perhaps give us a bit of insight into what the hardware and software is that's being used, how reliable it is. Presumably it involves and requires internet connection for whatever we're doing here. Yep.
Yeah, I guess again I'll start, we'll pass the mic that way. So, I mean, on the hardware side, if you think about how many homes we've got in the UK, there's around about 28 million homes. The vast majority of those are going to need some infrastructure changes, whether that's a new heating system, extra insulation, and that could be roof insulation, wall insulation, underfloor insulation, new windows and doors. All of those things will be needed in at least some way in individual homes across the UK. So this is a really big infrastructure change. Like 28 million homes is roughly about 400 homes every hour, every day for 26 years. Like that is huge in terms of what if you're here, you're interested in this sector. This is a growth sector for the UK if we're going to meet net zero by 2050. There are going to be some things we need to rely on, so we definitely do need to have good, reliable internet connections. So there's other infrastructure that needs to be there as well. That could be broadband. That could be connections up to phone signals as well, depending where you are in the UK. So you are going to need that underlying internet connection to make this work. And we've seen with the smart meter rollout in the energy sector that isn't always reliable, and there's certain infrastructure upgrades that we do need to allow those products to work as planned. I think in terms of reliability beyond that, there isn't much of a difference between electric products and, for instance, fossil fuel products. I mean, your gas boiler won't work or your oil boiler won't work in a power cut. Electric products would be the same, so we need to make sure that the grid is really reliable as well, because you want to maintain that constant electricity supply. The UK is very fortunate in that we have some of the most reliable electricity in the world. You wouldn't always think that with the sort of mood music around the energy sector, but over the last 30 years, the amount of power cuts has fallen, the duration of those power cuts has fallen as we have invested in the grid. So it's going to be more of the same in that regard, but yeah, absolutely, you're going to need to do lots of infrastructure, and that infrastructure is going to include both what's going on in the home and also things like broadband as well.
Yeah, just to echo what Tom was saying, I think there's only so much you can optimise. Physical interventions in homes are needed. If you've got a really leaky Victorian house, no insulation, you can make it as finely tuned as possible using software solutions. But at the end of the day, you need to make the fabric of the building, you need to make the heating systems and whatever it might else be better. So that's going to be needed. In terms of infrastructure and connectivity, our product is enabled through the cloud. So we use Wi-Fi, but we do recognise that is a barrier to some. It's really easy to forget that not everyone does have a Wi-Fi connection. And so we're developing ways to use 4G and other networks to make sure that we can reach all parts of the country and all possible consumers.
There's a few parts to it. I suppose it's all been covered. So you've got your heating. I see it as there's multiple functions in the home. All of those different functions use energy. You've got your heating, your hot water, EVs are coming through now, but it's also your cooking, your washing, all of these different things, and that all needs to integrate together. So I see one of the key challenges, and Tom brought it up right at the very beginning, is how do you integrate all of that together? How do you get it into a single app? How do you get them to work together? One of the problems you have around at the moment is everyone's got an app for their EV, they've got an app for their heating, their app for their lighting. People don't want to be using lots of little apps. And the other problem you have is they don't interact. So you have motion sensors for your lighting, you may have motion sensors for your burglar alarm, maybe you have motion sensors for your heating, and they're all separate units which are not integrated together. So getting that to work together, to integrate together, means either you have closed solutions, which is kind of the route that we went, where we basically built in all the bits ourselves and we picked items that we could control to build a complete solution. Or where you want to get to, I suppose, is an open standard where all of these things have standardized ways that you can work with them, that you can connect to and make them work. And unfortunately, we're not there today.
Great, thank you. I think so. The sort of final area that I want to sort of delve into a bit more is around the market appetite for the solutions we're talking about here, looking forward, and who the early adopters might be, sort of target markets, and any sort of barriers to this. So yeah, keen to sort of hear thoughts on this, really.
Okay. Right, from our perspective, or from my perspective, what I've seen is the people adopting this sort of technology are the early adopters, the innovators. And those innovators tend to be people self-built, building their own homes, so a lot of the audience around here. It's the eco-house builders, the people that are building homes to differentiate themselves as a sustainable builder. We've seen a lot of it from social housing. So social housing providers, being not-for-profit, are more willing to put expense in, even though it won't necessarily return something to them, but it will benefit their tenants, and they're doing the right thing. They're decarbonising, they're reducing bills for their tenants. We do see some of the bigger players dipping their toes in the water, but given that most of this adds an incremental cost to the home, we've seen most of them be, so far, somewhat loath to take that step forwards to add the cost, because they're not sure that they can recuperate the cost back from putting this technology in place. So until it becomes mass market or it's imposed by regulation, I see it still being a bit slow.
One of the things we historically struggled with was the regulatory landscape with regards to innovation in the built environment in the UK. It took a long time, good few years, but we managed to reach a point now where it's become less of a barrier. But things like recognition within the EPC, so the SAP, takes a long time. It's very opaque exactly how that works. Similarly, standards, which I mentioned, PAS 2030. There's not a clear route for a new emerging technology to be compliant with all these different standards. And again, it takes a number of years to navigate through and find a route to allow for adoption at scale.
Yeah, absolutely. I'd just add, I think Innovate UK have been doing some really good work trying to open up things like SAP, so that if you are an innovator, it is easier and takes less time for products to get through. But that's not much help to someone like Erics, who've already been through the process over like the last 2 or 3 years trying to get in through the Appendix Q process. I think there's a couple of things. On the electric vehicle side, I think it's a good comparison to what's happening on heating and buildings, because if I go back 10, 15 years, I used to work for British Gas, and we had an electric vehicle product and a tie-up with Nissan 15 years ago. But we weren't really doing anything about heat pumps, and other energy suppliers weren't really doing anything about heat pumps or electric heating. And you could argue that someone like British Gas, there's a very clear vested interest as to why they wouldn't want to be going down that route at that time. But even 3 or 4 years ago, there wasn't an awful lot of focus on electric heating, and that has completely changed. There was a whole clean heat team within the Department for Energy. Ofgem are focused on it. There is a lot of private sector money going into clean heat, both from institutional investors and from elsewhere. So I think we are beginning to see heat become more of a thing in a way that transport has become more of a thing to electrify. I think the adopters we're going to get on electric heating will probably be those who've already moved on electric vehicles. If you've moved to an electric vehicle, there's a reasonable chance you've done that, because there is still a slight premium for EVs, because you want to try and reduce your carbon emissions. It might be because you're trying to reduce your running costs, but I think most people go to electric vehicles because of carbon emissions. I think that's where people are going to come at electric heating from as well, to start with. I think Mark's already mentioned the future home standard. I think that will be another big driver. So if you're buying a new build in 2027, 2028, you should be buying a property which has electric heating in it, and it should be fairly well automated. Now, some of that depends on where we get to on the final regulations that come in 2024, 25. Some of that will depend on the quality of the build work that happens within the property, and to some extent that's beyond the control of people like us on the panel. That we can help make the products work, we can help make the regs work, but if then the builders need to go and deliver it when they actually build the properties. But let's assume that most of the properties from 27, 28, so 200,000-300,000 a year, will be good quality homes with lots and lots of automation in them and lots of electric heating, electric transport, EV chargers, solar panels, and flexibility built in as well. So, I think those are the two main routes. And as I say, over time, we're going to see more and more people adopt these products because the prices will come down, the carbon emission benefit will go up, and it'll be the product you want to buy for your property. It'll be the sort of thing you want to show off to people when they come round saying, look, I've got a heat pump, or in the way I think people today do that a little bit with EVs.
Great, thank you. I'm keen to make sure we've got plenty of time for questions with the audience. So, very last points from the panel. You've got up to 30 seconds each, no more. If there was one policy change, one further technological innovation that will support carbon reduction, cost reduction, or any other of the benefits we've been talking about with smart systems, now's the time to make your pledge.
I guess on the policy side, I think delivering market-wide half-hourly settlement by 2025, very technical policy thing in some ways, but it is the thing that enables time-of-use tariffs to take off. So getting Ofgem, the energy suppliers and DESNZ to make that happen on time is absolutely key. And if energy suppliers don't offer good tariffs on the back of it, having a backstop mandate to make sure that they do.
Mine would also be a policy thing, and it would be for DESNZ, Ofgem, BSI, Trustmark, and everyone involved in the regulation of domestic retrofit to set out a clear roadmap for how innovative technologies can comply with all the relevant standards and regulations to enable scaling.
I was going to have Tom's, but he beat me to it. So half-hourly billing and half-hourly tariffs would be a big one, and seeing those rolled out. So I'll pick the other one that came up a few times, which is SAP and support for innovation. It's a chicken and egg problem. If you are not part of SAP, you can't get your technology rolled out at scale to get the data to get into SAP. But because you're not in SAP, you can't roll it out. So you're kind of stuck. You don't have the data to go and show off to people to show it works. So we need a better innovation route for showing off smart technologies in SAP and EPC ratings.
Great, thank you. So thanks to my panelists here for sharing their insights in this really interesting area. We've got 8 minutes, so keen to field any questions. We've got a mic, so please introduce yourselves, who you are, who you work for, and ask your question. Oh.
Me? Oh, okay, right. Hi everyone, I'm John Saltmarsh, Chief Technology Officer at the Energy Systems Catapult. Great insights, really enjoyed the talk, so thanks very much indeed. Going down into the details, currently if you buy a heat pump, you size it for the coldest day of the year, and the idea is that on the coldest day of the year it's running 24/7 the whole day. How do you deliver flexibility if you can't turn off the heat pump when you really need it? Should we be resizing heat pumps to provide us the flexibility headroom?
So a very interesting question there. Mark, do you fancy taking that one on?
Well, there's two aspects to it. If I take it from a new build perspective, actually I don't see it as a major problem. So we monitor new build. If you look at a new build house built to current building standards or what future home standards will be, you lose maybe 1 or 2 degrees during a 24-hour period, so your heat pump is going to work absolutely fine. This is why they work well in Nordic climates. The issue comes into retrofit in my perspective, and it comes down to this improve the fabric. And the biggest problems that we run into in retrofit projects are where we put the tech in, but the fabric hasn't been improved, so the expectations on the part of the occupant of that home, the owner of that home, are not met. Exactly as you say, you end up using way more energy for heating, your bills go through the roof because you're using electricity rather than gas, and the customer complains like hell, and they blame the heating system rather than the fabric. So I'm not quite sure what's the way around it, but it comes down to get the fabric right, and the rest of it works fine.
Thanks for the question, John. If you don't know John, John's one of the good guys working on energy policy. He formerly was a colleague of Alex's at DESNZ. So I think certainly for hot water, I think there's a case for oversizing the hot water. If I think of, like, for instance, the SunAmp, who are a Thermal Storage UK member, you could oversize that product and take up less space than a traditional hot water tank, and you could utilize that for flexibility all the way through the year, including on peak days, but also on off-peak days all the way through the summer. I think for heat pump sizing, there's questions really there about whether you're sizing the property using a high temperature or low temperature heat pump system. Low temperature, I think the case for flexibility is lower. High temperature, it's higher, nicely, which works quite nicely in terms of remembering those things. And if we end up with a rollout that's predominantly high temperature heat pumps, there may be a trade-off between flexibility and the efficiency of the system.
Thank you. Any more questions?
I'm Graham Heinson. I'm a technical manager at Gilbert and Good, based down in Cornwall. You've talked a lot, and it's been really interesting, about active systems. I'm just wondering if there's a place for passive systems and how that would integrate with some of the smart technologies that you're talking about. Passive heating through solar gain primarily, I guess, or passive ventilation as well.
Well, actually, Eric's is a type of passive ventilation. So we are managing passive ventilation, so that the advantage of that being we're able to be easily retrofitted into existing homes. So we're taking the place of existing passive vents and just optimizing the ventilation through it more. I'm really overstepping my expertise, but I think with heat pumps and the like, it's about incorporating solar gain and the like into the design and ensuring that everything is specified, incorporating all aspects of heat inputs and outputs to the building. So looking at passive gain, losses through fabric and through infiltration.
I think there's a major place for passive systems. So it's definitely one of the areas that we're going and looking at. So how do you do passive heating, cooling? So very simple example, cold winter's day, sun's shining, how do you maximize your solar gains? Through the automation of blinds, for example. So if you've got that understanding of the weather, the impact of the solar gain, the brightness within a particular room and the temperature in a particular room, you can automate your blinds to open as the sun's shining. But on the flip side, overheating is becoming a major issue. So on a hot summer's day, close those blinds down, block out the solar energy and open windows automatically at the back of your house or the top of your house to go and release energy. So there's definitely a part to play, and I personally believe it's not looked at enough right at the moment.
I saw that there were some more hands up. Maybe a chap here.
Hi, Tom Wilson from Jazz Electricity. You spoke a fair bit about the importance of building momentum with electrification of heat and things through public awareness of the effectiveness of some of these things. To what extent do you think public awareness, perhaps through something like an EPC rating being attached to a property type, will affect the property price in the housing market and therefore drive consumer uptake?
There's a lot of data out. I actually got asked this question over the weekend, weirdly enough, from somebody else internally. But there's data out that says, and I've seen it before, higher EPC ratings result in a higher price. However, if I go and look at the EPC rating of new build homes, only 4% of all new build homes are built to an EPCA standard. What that tends to indicate to me is that our major house builders don't believe that they can get more money for a higher EPC rating, or at least they can't get it from the majority of people out there. So there is a minority, or there is a percentage, let's put it that way, of people that are willing to pay more because they want a better home, they want the lower bills, they believe in doing what's right for the climate. But I think there's an apathetic majority that's not ready yet, and there is more work needed. So it's a bit of both, really. But
my understanding from the research that's out there and my own kind of personal experience is that it may form a part, but it's a relatively small part compared to location, size, other characteristics of the property. So it'll all be part of the mix in the same way that any other thing is, but never the driving force.
Yeah, I think a couple of things. So one is that in the UK, we've only got about 60% of homes have an active EPC. So if we got closer to, say, 90 or 100%, you'd have a much better pool to work out whether or not there is a difference in terms of the actual property value. With the 60%, I agree with Mark, there doesn't seem to be a huge difference between an EPC C-rated property and an EPC F-rated property in terms of the value of that property. But people will look at the property and think, oh, there's going to be lower running costs. That may play in at the margins, at least, to their decisions. But location is why you buy a house. It's that's still going to be the driving factor, I think, in most cases. I think the other thing is that we know EPCs don't work as well as they should. Like, if you've looked at EPCs, there are lots of problems with them. I'm a retrofit assessor and retrofit coordinator, so I see those day to day whenever I'm looking at the SAP software. But there are other things that have been proposed, like the smart building rating. Now, the smart building rating is something that the Centre for Net Zero have pitched as an idea to go alongside EPCs, and that would tell you how flexible the property is based on the products installed. So we've been working closely with Octopus and Centre for Net Zero and Energy Systems Catapult and others on trying to develop that idea, because we think that could be a good way of signalling the value of the property in terms of different running costs.
I'm afraid we're going to need to wrap up. We've hit 2:00, but first I just want to say a big thank you to the audience for coming, because without you being here, we'd have no one to talk to. So thank you for joining us today. Thank you very much to my panelists. Excellent insights. I'll be hanging around. Panelists might be around for a bit. If you've got more questions, you can come and find us. But if you want further information on any of the innovation projects receiving funding through Department for Net Zero's innovation portfolio, NZIP, and Innovate UK's Net Zero Innovation Programme, we've got our stands around. Look on the internet. We've got our next session at 2:15. So please stay with us for that, on fast-tracking innovation, barriers to the adoption of innovation in the energy efficiency retrofit market. And that'll be curated by Sustainable Energy Association. Thank you very much, and see you all soon. Thanks, bye.